Hey guys, so what we're going to look at right now is we're going to look at what's called the conical tank problem. It's a very, very common problem that appears in high school, university. It, sh- it shows up on a lot of exams. It shows up very, very commonly. So let's dive right into this bad boy. A water tank is built in the shape of a circular cone with height 5 meters and diameter 6 meters at the top. Water is being pumped into the tank at a rate of 1.6 meters cubed per minute. Find the rate that the water level is rising when the water is 2 meters deep. So you guys will see that I've already pre-drawn out my cone. Think about how many tries I probably had drawing this cone, and this was the best that I came up with. But notwithstanding, from there, we can label the values that do not change on this. So looking at my values that don't change, I have that the height is 5 meters and I have the diameter 6 meters at the top. So knowing that, we have that this height right here is going to be 5 meters. And I know that this value right here is going to be 3 meters. Why? Because radius is half of the diameter. Now, looking at this problem, what's happening, and I'm going to use blue because everybody knows that water is blue, we have that the water level is rising right there. And this cone is filling with water. Now, these are the changing values. As water is poured in, what will happen is my radius will change and my height will change. So I'll label this as being R and I will label that as being H. Now, we know that the volume formula is V equals 1 over 3 pi r squared h. And we're going to go on a side for a second with this question. Let's say, and we're just going to take this up here. I'll draw a little segue to show that we're going on a little segue right here. But let's say that I wanted to take the derivative of 1 over 3 pi r squared h. So I take the d over dt of this, which will give me dv over dt equals, I'm just going to take the 1 over 3 pi, or the pi by 3, out of this, and I'm going to have the d over dt of r squared h. Now, looking at the d over dt of r squared h, I'd have to use the product rule on this. So we'd get dv over dt would equal pi over 3, and then this would all get multiplied by 2r dr over dt h plus r squared dh over dt. Now, I'm not going to bother expanding this because I'm just trying to get to a certain point right here. If we look, I don't have a lot of information in this question. I have 1, 2, 3 pieces of information. And if we look right here, we have a lot of variables that would need to be filled in. Now, there are cases of this question where you'll be given enough information in the question to do it with this method, and there are cases of the question where you'll have to find your way to the end and then go back and substitute something in to this form right here. But this is not the common way the question presents itself, so we're just going to stick with the more common way this question works. And what we're going to do is we're going to try to reduce the number of variables in my original equation. If you remember, we said that manipulations are completely fine in when we're looking at the original equation, when we're talking about related rates. So looking at this right here, lo and behold, what do I notice? I notice that I've created similar triangles. So I have the 3 right there, I have the 5 right there, I have the r right there, and I have the h right there. At this point, I can use my similar triangle relationship that r over h equals 3 over 5. Now, what we're looking for is we're looking for the rate the water level is rising, which is going to end up being my dH over dt. So I'm going to solve this for r. We get r equals 3h over 5, and then I make that substitution, 1 over 3 pi 3h over 5 squared, all multiplied by h. I then am just going to simplify this out a little bit. We get pi over 3, and then 3 squared is 9, h squared is h squared, all over 25, and then I multiply this by h, which will give me v equals 3 pi h cubed all over 25. So we get 3 pi h cubed all over 25. Now, the next step that I'm going to do here is I'm going to take the derivative of this. And we again have to remember that the 3 pi over 25 is just a coefficient, so I'm just going to be using that power rule on h. This will give me dv over dt will equal 9 pi h squared, because the derivative of h cubed is 3h squared. And then this will all be over 25. And by that chain rule, we need to remember to multiply that by dh over dt. From here, we look and we see that the water is 2 meters deep, so that means that my h is going to be 2, which will give me dv over dt equals 9 pi 2 squared all over 25 multiplied by the dh over dt. And then also I have that my volume, the water being pumped into the tank, is 1.6. So I probably should have done this before, but I'm just going to do it right now. Thank you, the magic of the eraser. And I get, try that again. And I get 1.6 equals this. Now I realize it's not common that we end up with both a decimal and fractional values. So what I'll do is I'll state the answer in two ways. Most likely what I'm going to expect of you guys is to give me a fractional answer, which would be 10 all over 9 pi, 9 pi, 9 pi. But we have that that's also approximately equal to 0.4. So yet again, taking my sweet multicolor, we get that this is our answer. I hope you guys have enjoyed.